were given the topic of primary energy, naturally we focused on using solar energy as Singapore has sufficient sunlight to make it a viable source. We also decided that HDB flats were going to be our target group as they made up about 40% of Singapore's electricity usage. When we zoomed in on HDB flats, we found that roughly a fifth of that energy was used by appliances that convert electricity to heat. In essence, what they needed was the heat energy, not the electricity. And the thought came to us that if we could find an alternative source of heat, we could be saving a lot of energy. To make the idea viable, we needed to be able to store the heat energy in the sense that we needed a concrete battery. This enables us to utilize the heat energy even at night when there is no sunlight available. From our research, materials such as concrete, water and sand were the best in storing thermal energy, and metals such as copper and aluminium were the best conductors of heat. But by looking at HDB flats, we found that they were built mostly with concrete with aluminium structures already embedded in them. And so with this in mind, we decided to go with concrete and aluminium. And this gave rise to what we call the concrete idea.
Why concrete? Concrete has a low thermal conductivity of 0.3. This would mean that heat has difficulty passing through the material itself. This would also imply that heat energy is being stored within the concrete. As such, because of its dense material, it acts as a thermal mass, holding heat energy in the day and radiating out in the evening. However, heat is unable to be stored within the entire block of concrete because it is unable to transmit heat fast enough. As such, you will require metal or something which have a high metal conductivity to conduct heat energy, to conduct the energy across. This can be done by adding two different metals into the concrete.
So with the aim of storing and transmitting heat in our design, we actually have the basic idea of running a pipe through the concrete such that the water that flows through it can actually tap on the heat that has been already stored within the concrete. However, we felt that there were things that we can do better to optimize our design. So we actually had a few prototypes that have varied factors such as varied orientation of the plates, like whether it's being placed vertically or horizontally. So what I found out is that if the plates were placed vertically, the spread of heat is actually better for the conduction of the heat to the water. And secondly, we have also varied the number of loops. So from what I found out is that with more number of loops, the water actually stays within the concrete for a longer period of time. So that to say, it has actually more heat to conduct, more time to conduct the heat into the water. And then thus, we have actually decided that with more loops, our design can actually get better. So the third factor that we varied is actually the capacity of the heat storage limit within this concrete. So meaning to say, if this concrete is actually bigger in size, there is actually more space to store the heat. So our design can actually be possibly optimal because of the large size by nature.
Right above our HDB flat locates a massive water tank of 32 meters by length, 6.3 meters by breadth, and 2.3 meters by height. This water stored is actually stored for domestic users. As such, we decided to use the water tank and combine the idea with our concrete idea. The water flowing out of the water tank can be transmitted into our homes by first running through the piping system that's embedded within our concrete, which means our concrete will be capable of heating it in a day via conduction and at night, heat it via radiation.
The first advantage of our idea is that it's much cheaper to implement as the materials that we need are already part of the HDB structure. This means that what we need to do is optimize the internal layout and arrangement of the components to make it more effective for our purposes. Unlike existing idea like black pipe heating, ours is more advantageous because black piping loses its effectiveness at night or when the temperature drops. but our stored heat is still able to heat up the water under those conditions. Backpiping is also much less durable than our idea. All in all, this makes it a much more feasible product.